part 2 is going to be all about graphing. For each of these, you're going to identify domain and range, except for the ones with the inequalities. And let's go ahead and start with what the graphing is going to look like. So when we have ones that are linear, you can tell it's a linear one because there's no exponents on either of the variables, and there's an x and a y. And there are no absolute value bars. Step 1 is going to be to solve your equation for y. So you have 2x minus y equals 5. And this is just basically getting it in slope-intercept form. So we need to get our 2x moved to the other side to get it away from the y. And we have negative y is equal to a negative 2x. And the 5 is positive, so we put plus 5. Now we've got to get rid of the negative sign. So I'm going to divide everything by negative 1. Y equals 2x. And that's like 2 over 1x minus 5, because 5 divided by negative 1 is negative 5. And so out of these things, we're going to need to identify your slope and your y-intercept. And your y-intercept is the number at the very end with its sign. And that's going to be at 0, negative 5. It's always 0, it's always going to be on the y-axis because it's the y-intercept. The slope is going to be your rise or fall, depending on if it's positive or negative, over your run. In this case, my rise is 2 because it's positive, and I'm running 1. Now I'm going to come over and graph that. So my y-intercept was negative 5. And from there, I rose 2, went right 1. Rose 2, went right 1. And I keep doing that until I get off my graph paper. And then I come back and I draw in a line. And I put arrows at the end of my line. And I am done with the graphing. The next part of the question asks me what is the domain and range. For these, anytime you have a linear equation, the domain is always from negative infinity to positive infinity, and the range is the same thing. Let's do another one. So again, the first thing we're going to do is solve this equation for y to get y by itself. So I need to move the 4x over. And I end up with negative 5y is equal to a negative 4x plus 5. This time I'm going to divide everything by a negative 5. End up with y is equal to 4/5 x minus 1. So again, we're going to identify our y-intercept, which is going to be 0, whatever is at the tail end, and our slope. This time we have a slope of 4 over 5, so that means I am going to rise 4 each time and run 5. Because it's positive, I'm rising. If it's negative, I'm going to fall. And this is always going to be running right. To do left, you just reverse both pieces. So let's start with my y-intercept. My y-intercept is at negative 1. And so from there, I'm going to rise up 4, and that puts me at positive 3, and run right 5. And so that puts me at 5, 3. But I can draw the line between those two, but I'm not going to be as accurate. So I'm going to see if I can fit going back to the left. So going left, I need to reverse both pieces. So I would fall 4. So that put me at negative 5 for the y. And run right, or run left 5. So again, to go back to your left, you need to reverse both. So if you're going left, and you would need to fall. Now I'm going to draw my line and put the arrows at the ends. Let's identify our domain. And again, I have a linear function, so my domain is all reals. Range for any of these linear functions is going to be negative infinity to positive infinity. Now let's look at number 3. Start the same way. 7x plus 4y equals 12. So I need to get the y by itself, so I'm going to move the 7x over. And we have 4y is equal to a negative 7x plus 12. Divide everything by 4. And y is equal to a negative 7/4 x plus 3. So my y-intercept is going to again come from the end. And my y-intercept in this case is 0, 3. My slope is going to come from what's in front of my x. This time I am negative. And so I am going to fall 7 right 4. So my y-intercept is at positive 3. I'm going to fall 7 from there, so that's going to put me at negative 4 on the y. And I'm going to go right 4. So my ordered pair for that is 4, negative 4. Now if I was to reverse both, that would put me at rising 7, and that gets me off the graph. So there's only 2 points I can actually plot on my graph paper. So I plot those 2 points, draw my line between them, put my arrows on the end. Now let's identify our domain and range. The domain, again, I have a linear function, so it's negative infinity to positive infinity. Range is going to be the same thing, negative infinity to positive infinity, because I'm covering all the x's and I'm covering all the y's. The last one, linear ones that you had to graph, is x minus 2y equals negative 8. So again, I need to get the y by itself. So I'm going to move the x over, which gives us negative 2y is equal to negative x minus 8. Now everything is going to get divided by a negative 2. And I have y is equal to 1/2, because that's a 1 in front of here, even though it's not written. And so those two negatives will cancel out. 1/2 x plus 4. So again, identifying my two pieces. Y-intercept is 0, 4. And my slope is a little bit different this time. And that I am going to rise 1, run right 2. So plotting my y-intercept is going to be at positive 4. And so from there, I am going to rise 1, go right 2. So I'm rising up to 5, moving over to 2. Then we'll do it again. Rise 1, right 2. This puts me at 4, 6. Now reversing both pieces, I drop 1 or fall 1, gets me down to 3, and go left 2. Drop 1, go left 2. Drop 1, go left 2. And that gives me some more points to plot. And the more points I have, the more accurate my graph is actually going to look. So I'll usually go through all the points I can. Put the arrows on the end. My domain, again, I'm dealing with a linear function, negative infinity to positive infinity. My range is negative infinity to positive 8. I left these two types of equations off your assignment, but I wanted to go ahead and go over those real quick. Just a little sketch of the graph and what it would look like. So those are my axes. This is my X and Y. Now, when X equals 7, that means at 7, I'm going to have a line that just goes straight up and down. So everywhere on there, the X is equal to 7. This one's domain is just the set of 7. The range on the y's, I'm going to end up covering all the y's. So that's going to be the negative infinity to positive infinity. Now, when the other is true, the opposite way will happen whenever we're dealing with y equals negative 2. So y equals negative 2, that means I go down 2, and everywhere along that line is where that y equals negative 2. And so, this case, our domain is the negative infinity to positive infinity because I'm going to cover all the x's. My range is only that negative 2.